This question is about the conservation of momentum in collisions in two directions. 1, 2. Making the math operations more complex compared to collisions in one single direction. If you want to learn how to analyze questions like this, follow along and take some notes. This question is from AS Physics Exam, May-June 2016, paper 23, question number 5, which is available online. You can download this question to follow along with this video or take notes with me. Make sure to set your calculator to degree mode. I assume you have a basic knowledge of the momentum formula and its applications. If you want to master solving questions like this, you are in the right video. So let's begin. Question number 5A. This question asks to state the principle of conservation of momentum. In an isolated system, the sum of momentum before is equal to the sum of momentum after collision. To receive 2 marks for this question, you must include the phrase in an isolated system or free of external forces. Section 5B. 2 particles A and B collide elastically as illustrated in this diagram. This is the description of this diagram. The initial velocity of A is 500 meters per second in the x direction and B is at rest. The velocity of A after collision is VA at 60 degrees to the x direction. The velocity B after the collision is VB at 30 degrees to the x direction. The mass m of each particle is 1.67 times 10 to the negative 17 kilograms. Now, here is the question. Explain what is meant by the particles colliding elastically. The answer is the total kinetic energy before is equal to the total kinetic energy after collision. Question II. Calculate the total initial momentum of A and B. So right here in this pink box. We are using the formula for momentum. P is equal mass in kilograms times velocity in meters per second. In this table, we have the information that we need to answer this question. The mass A and mass B are equal. The initial velocity for the particle A, 500 meters per second, and particle B is at rest, so its velocity is 0. The initial momentum, Pi, is equal to the sum of the initial momentum of particles A and B. In this first step, let's do formula substitutions, just using abbreviations. Then we can substitute the values from the data table. In this step, let's do some calculations. And here is the finale. The initial momentum is equal to 8.35 times 10 to the negative 25 kilograms meters per second. This is the unit for momentum. But wait a minute. The unit here is showing NS, which is Newton second. Let's check this out. There are two formulas for momentum. One is mass times velocity, and the unit for mass is kilograms, velocity is meters per second. So the unit for momentum here is kilograms meters per second. The second formula is force times time. So the unit for force is Newton, the unit for time is second. So the unit for momentum is NS, or Newton second. So it doesn't matter which unit here we use for momentum. And be careful with this because it might confuse you. But I hope that explains everything. Now let's move on to the next question. Question III. Here is asking to write an expression in terms of m, va, and vb for the total momentum of A and B after the collision in the x direction and in the y direction. To answer this question, let's draw the VA x component and VA y component for the velocity A. And here we have the table with the expression for each component. For VAX, or VA at the x, in the x direction, is VA, the value of VA, cosine of 60, because it's close, cosine close. And VAY will be VA, sine of 60, because VA is away from 60, then use sine. So let's use the same process to determine the components of the velocity B. Here we have the x component and the y component. The x component is close to 30 degrees. So the expression is VB, which is the value of the velocity B, cosine of 30, and the vertical component, or y, is away from 30, so we are using VB times sine of 30. Here we have the velocity components of both particles A and B, along with their corresponding trigonometry expressions. To find an expression in the x direction after collision, we have to look just VAX and VBX. Now, to write in terms of momentum formula, which is mass times velocity, so it will be the mass of particle A times this x here indicates multiplication times VAX plus, because both are in the same direction, to the right. The mass of particle B times the velocity of B in the x direction. Now let's make this expression here a little bit better. Now, after substitutions of each component, this is the final expression that we can write in terms of M, VA, and VB. We could simplify a little bit more and place just the mass here, and I think it looks good. And all right, just it. So let's take a look in the y direction. In the y direction after collision, the momentum upward is equal to the momentum downward. So here is the expression. So it's mass times the vertical component of A is equal to the mass times the vertical component of B. And in this table, we have the expression for each component in the vertical direction. So after substitutions, we have this expression. We could eliminate M, but the question asking to include M, VA, and VB. So just leave like this. Last question is asking to calculate the velocities VA and VB after collision. To answer this question, we need to work with conservations of momentum in both directions simultaneously. So I have each expression side by side. In the y direction, the momentum is the mass of particle A times the component VAY, which is VA sine of 60, right here in this data table. And the momentum in the y direction, but downward, is m, the mass of particle B, times the vertical component of B, which is VB sine of 30. Now let me work with the x direction. In the x direction, we have to look from before collision and after collision. So before collision, we have the mass of particle A times 500 plus this one here is at rest, so I'm not even going to include in this expression here because it's 0. Now after collision is this section right here. So by the expression that we derive in the last question, so we know that the mass is the same times the velocity in the x direction, which is VAX. I'm going to substitute with what I see here, which is VA cosine of 60 plus the velocity B in the x direction, VBX is right here, VB cosine of 30. So now we have our first step with all the substitutions in terms of x and y directions. So let's look in the y direction. We can first cancel the mass from both sides. So what is left is VA sine of 60, which is equal to VB sine of 30. Then we can rearrange this expression in terms of VA. So VA is VB sine of 30 over sine of 60. So now I have an expression of VA in terms of VB. When work with expressions like this, I would recommend to leave sine and cosine as it is, without calculations yet. There are some results with many decimal places, and it can be quite confusing when writing values. Now here, nothing that we can do, so let's move it to momentum in the x direction. So my first step is to cancel m, and rewrite the new expression. Let's substitute the expression of VA in terms of VB from the Y direction to the X direction. So I hope you are not lost, but if you are, just pause the video and play back a few slides to see the steps. Now you can use your calculator and do sine of 30, sine of 60, cosine of 60, cosine of 30, and we have this result right here. So 500 is equal VB times 0.288 plus VB times 0.866. So now everything here is in terms of VB. 500 is equal to 1.15 VB, and voila, VB is equal to 433 meters per second, or just 430 if you prefer to write with two significant figures. Now, substitute 433 meters per second, which is the value of VB, in the expression for VA. Now, do your calculations, and we have the value of VA, which is 250 meters per second. So, we have reached the end of this question and this video. It was quite math intensive, and it can be stressful on exam day to answer a question like this under time pressure. But if you understood all these steps, I'm sure you can replicate them for similar questions. Now I don't know about you, but I need a break before resuming my studies. Goodbye.